This is Geometry, Chapter 4, Section 6, in which we will go a little further in depth on isosceles and equilateral triangles. Remember, we said isosceles triangles have at least two congruent sides. We're going to really just focus on the case where it's exactly two. The two that are congruent we call the legs of the triangle. Don't get that confused with the legs of a right triangle. Okay. In an isosceles triangle, the legs are equal. In a right triangle, they don't have to be. It would seem to me they could have picked different word instead of legs for both of them, but they didn't. The third side, the side that is not one of the legs, is called the base. Okay. So that distinguishes the sides. Now let's talk about the angles. The two angles that are on the base down here have a special name called the base angles. And the third angle, you can already see, is called the vertex angle. Now this is only going to apply to isosceles triangles. That's important to remember. The two legs are the same, they're equal, and then the base is the third side. The two base angles are on the base, surprisingly, and the third angle is called the vertex angle. Okay. Now there's a nice idea here, specifically referring to isosceles triangles. If you have two sides, so you can call the isosceles triangle theorem, if you have two sides of a triangle that are congruent to each other, then the angles across from those sides are also congruent. Another way to say this is the base angles are congruent to each other. Okay. And the converse is also true, and it's its own theorem as well, the isosceles triangle converse. If you know the two base angles are congruent, then that tells you that the sides across, the sides opposite from them, are congruent. I'm going to jump back to be able to point at those on the picture here. If you know these two angles, this one and this one, are congruent, then you know that side would be congruent to that side. That's what the converse says. The theorem itself says if you know the two sides are equal, then the two base angles, the two angles opposite those sides, are congruent as well. Okay. These two theorems go hand in hand. Now, just like before, we have a couple of corollaries to talk about. 4.3 corollary tells me if I have an equilateral triangle, that means it's also equiangular, and the converse is true. If it is equiangular, then it is also equilateral. That's what this if and only if means. It means you can go both ways. Knowing you have equilateral also means you have equiangular. Knowing you have equiangular also means you have equilateral. Okay. And this idea comes from these two theorems. Congruent sides mean you have congruent angles. Well, if all three sides are congruent, then all three angles are congruent. And furthermore, if you have an equilateral triangle, you know each of the three angles has to be 60 because they have to add up to 180. They're all equal, so 180 divided by 3 is 60 degrees for each one. And if you don't remember that corollary, you can always figure it out just like we just did. 180 divided by 3 is 60. Okay. Let's apply these ideas and see what we can figure out. Our first job is to figure out the measure of angle M. And they've got it marked that the measure of angle M and the measure of angle P are the same. Okay. We know the three of these add up to 180. Well, if I take this 120 out, that leaves 60 degrees to share between two angles. So 60 divided by 2 tells you each of these two angles is 30. Now, since these two angles are congruent, the opposite sides are congruent. So angle P leads to a 13. That means angle M must lead to a 13. So PN is 13. Okay. One more problem to consider here. We need to find the values of the variables. Okay. We have some congruent sides, so that tips me off to something. Having those two sides congruent, I can write an equation and figure out what y is. Subtract the 2y over and add this 2 leads me to y is equal to 2. Now, again, since I know the sides are congruent, that tells me these two angles here are congruent. I have 180 degrees total. Get out of the way. That should be an equal sign. 180 degrees total, divide or subtract the 80 that we already know, leaves 100. 100 divided by 2 tells me each of these angles is 50. So 6x plus 8 is equal to 50. Subtract the 8 over, 6x is 42. So x must indeed be 7. Okay. The key ideas to remember here: equal sides lead to equal angles, and equal angles lead to equal sides. If you had questions along the way, hopefully you wrote those down as always. Bring those in with you, and we will see you in class.